Thank you for coming to the YouTube channel, Mr. Professor, or 교수아재 in Korean. In this video, we are going to handle some application of eigenvector and eigenvalue. Here is a gross model for the numbers of the computers and dogs in successive years. So if you know the numbers of computers and dogs this year, then you may get some information for the numbers of the sum of the computers and dogs in certain year. So from this system of a linear equation, you can express as a matrix product. So C prime D prime is equal to 3, 1, 2, 2, and C, D. So if you land this A, okay. So in here, we actually want to know A to the 20 and 20 and 10. So we just want to know an upper bound for the numbers of the sum of the computers and dogs in 2044. So you may want to think about the sum num of the matrix. So this, so you can think about the sum num of this one is at most the sum num of the matrix and 20 times the sum num of this vector, okay? Maximum column sum, you can get it from the first column, which is equal to 5. So this is a 5 to the 20 times and 2010, which is equal to the sum num of a 2010 is equal to 30. So we can easily get an upper bound for the numbers of the sum of the computers and dogs in 2044. I want to guess the numbers of computers and dogs in 2044 separately, then you may use the information about the eigenvalues and eigenvectors. Still, you want to know A to the 20 and 2010. But, well, it's not that simple to calculate A to the 20. It may take a long time, probably. Okay? But if you can express the vector 2010 as a linear combination of the eigenvector and eigenvalues, then probably it's easy. Okay, so first, let's determine the eigenvalues of the matrix A. So determinant of lambda I minus A is determinant of lambda minus 3, lambda minus 2, minus 1, and minus 2, this one. So this is equal to lambda minus 3 times lambda minus 2, minus 2, which is equal to lambda squared minus 5 lambda plus 6 minus 2, that's plus 4. So this is equal to lambda minus 1 and lambda minus 4. So we have two different eigenvalues. So lambda is equal to 4 and lambda is equal to 1. So now let's find the eigenvector corresponding to those eigenvalues. So for lambda is equal to 4, so we have 3, 1, 2, 2, and xy is equal to 4 times xy. Then you will have 3x plus y is equal to 4x, and 2x plus 2y is equal to 4y. So from this system of linear equation, you will get x is equal to actually y. So you can guess the eigenvector 1, 1 to the corresponding eigenvalue 4. Similarly, you can also determine the eigenvector of the eigenvalue 1 here. So from here, you will have 3x plus y is equal to x, and 2x plus 2y is equal to y. So from here, you will get y is equal to negative 2x. So you can think about the eigenvector 1 comma negative 2. Okay. So now you can express the vector 2010 as a linear combination of the eigenvectors and eigenvectors. So 2010 is equal to 8 times 1 plus b times 1 negative 2. Then you will have a plus b is equal to 20, and a minus 2b is equal to 10. Then you can have 3b is equal to, if you subtract, that's, yes, 3b is equal to 10. Then b is equal to 10 over 3. So if b is equal to 10 over 3, then here, then a is equal to, you will have 50 over and 3 here. Yes. So the 2010 is equal to 50 over 3, 1 plus 10 over 3, 1 negative 2. And we want to guess the numbers of computers and dogs in 2044, which means you want to know the a to the 20 and 2010. But the a at 2010, this vector can be expressed as a linear combination of the eigenvectors 1, 1, and 1, negative 2. So this is equal to 50 over 3, 1 plus 10 over 3, 1, negative 2 in here. So then you will have a 50 over 3 and a to the 20, 1 plus 10 over 3, a to the 20, and 1 negative 2. So if you use eigenvectors, then you don't need to compute a to the 20. It takes a long time. But this is an eigenvector, so we can easily express this one is 4 to the 20 and 1. And plus this is 10 over 3 and 1 to the 20 and 1 negative 2. Okay, so this is actually 50 over 3, 4 to the 20, 4 to the 20, and 10 over 3, and 1 negative 2 here. So we can easily guess the numbers of computers and dogs in 2044. Well, you may have a fraction, but you may have some approximation, maybe to a certain integer. Okay, so we can easily guess what the numbers of computers and the dogs maybe in 2044. Maybe the boss of your company will want to check with other initial vectors. Well, in that case, you want to repeat those things again and again with a different initial vector in here. Well, then it's a little bit work, okay? It takes time, right? It takes time. If the boss of your company probably want to check with many initial vectors, then it may take a long time. So in that case, probably you want to express the matrix A, U, D, lambda, and U inverse like this. And U is the matrix whose column vector is the eigenvector of A. So in this case, 1, 1, and 1, negative 2. And d lambda is equal to just the eigenvalues, 4 and 1 here, like this. And then you can determine U inverse, okay? Then probably you want to determine the 8, 20 in here. And then within many initial vectors, you just multiply in here. And then you can maybe guess the numbers of computers and dogs. Okay. So this is another method to guess the numbers of computers and dogs in certain years. Thank you for watching.